I don't remember. James Webb Telescope will get us back from currently 400 million years after the Big Bang to 200 million years after the Big Bang. So it's
Cool.
not going to completely revolutionize things because we already know a lot. The thing that might revolutionize things are these observation of gravitational waves. The
Ah, yes.
um, because before this we were unable to see black holes except when black holes were feeding on gas. And so now we can actually see two invisible black holes collide, and we'll learn more about how black holes were formed. So that'll be something new. And basically, anytime you have a telescope that allows you to see something you never saw before, you find out that you didn't know what the hell you were doing. And so
Ah,
already we've learned a tremendous amount of black holes that we didn't know. So, there's that. And then, of course, it's hard to know, like for things like CERN or something, if we have a bigger accelerator, maybe we will just be enough higher energy to see something new. It's hard to make predictions, especially about the future, as they say. So it's
cool.
hard to know.
Yeah. But the gravitational wave stuff is interesting, and the black hole stuff. Um, what was I gonna say? How what is the nature of a black hole? So, because I don't really know. I don't really understand it. Other than that, it's like a lot of just sucks everything in. Um, what does it really mean? Like, where does that stuff go, for example?
Just goes inside, makes it heavier. It's like um, stuff falling on the Earth, meteors and stuff falling on the Earth. It hits the Earth and makes it heavier. That's what it does. Um,
Does the
now,
does it
black
then
holes don't
does it
actually suck anything in.
okay, they don't.
Go ahead. No, I mean, if you took a black hole the same mass as our sun and put it where our sun is, took the sun, threw it away, put the black hole there, be no difference. I mean, they're just heavy stars. Now, if you get close to one, you can't get out. But it's not like it reaches out and grabs you or something any more than any gravity reaches out and grabs you.
I see. So what is the whole idea of this light can't escape thing? What does that mean then?
Well, if you get close enough to a black hole, the gravity is so strong, light can't get out. So, like the gravity on Earth is stronger than if you go 1,000 kilometers up. If you go a
Yeah.
thousand kilometers up, the strength of gravity is lower than it is here. So, if the strength of gravity increases the closer you get to something, then there comes a point where gravity is so strong that light can't escape. And that's all it is. I mean, it's just very strong gravity. But it's not weird gravity. It doesn't reach out and grab things. It's just if gravity gets so strong you can't get out.
Wow, that's very interesting. So does that have any relation to dark matter at all, or not?
No, well, probably not. There was a time where people thought dark matter was black holes might be a form of dark matter, but it was back in the 90s that we proved pretty conclusively that it isn't.
Interesting. I'm definitely gonna have to look into black holes and stuff. Um, so yeah, I think pretty much that's everything covered. Um, I mean, we started with the whole why is this stuff important? Or why should people care about it?